by introducing Davide. So thank you, Davide, for joining. Thank you for agreeing to give this webinar and accept to record it. Davide is a climate scientist at LSCE-IPSL in Paris. And he has a very strong expertise in statistics and focus on attribution of weather extreme events to climate change. And if you have the curiosity to have a look on his list of publications, this one is pretty impressive and showing a large diversity of application. And two examples in 2023, he contributed to work on Antarctic ice core records, providing evidence of Antarctic polar amplification, and also showing that CMIP 5 and 6 models fail to capture the amplitude of the natural and forced variability, or attributing Venice Acqua Alta events to changing climate change and evaluating the efficiency of the MoSE adaptation strategy, which presumably we'll more focus on today. So thanks a lot, Davide, and the floor is yours. We are very happy to listen to you.
Thank you very much, Gael, and good afternoon, everyone. So first of all, I have to apologize. I'm sick with a big flu, and this is the right window where the paracetamol is basically lowering my temperature to something that is acceptable to speak. I hope it doesn't go up. You will see if I say something that is probably not coherent. So please stop me in this case, and I will do my best to go through this topic. So this is the first attempt using what I will explain as conditional attribution to evaluate the adaptation strategy of the MoSE. It is a barrier which has been devised by the Italian government and the region Veneto to protect the city of Venice from the flooding events that are called Acqua Alta in Italian. So this work is in collaboration with Mireia Ginessa, who is my PhD student, who greatly contributed to the methodology. I will explain how. And then we have some colleague in Italy, Erika Coppola, who is an expert of Mediterranean extreme precipitation events. And then we have two colleagues from the INGV, Tommaso Alberti and Marco Anzidei, who are directly in contact with the city of Venice. And basically, we exchange a lot with this colleague to provide these products as output to have some kind of element to think on how well the city is protected. And you see also that there are several logos here. So one is ExAIDA. ExAIDA is a research project, a European research project that is focused on the attribution of extreme events to a changing climate using machine learning methodology. And ADP is a project where Mireia Ginessa, my student, is studying extratropical cyclones and their link with anthropogenic climate change. And Mireia is actually the first in the world who was capable to attributing the storm Alex, which affected France in 2020, to climate change, and she found an increase of the impacts of these storms in terms of strong winds and precipitation over Provence and over north of Italy. So let's start after this long introduction. I will also give you the reference at the very end of the talk. But before, I want to explain you what are these Venice Acqua Alta events. So you can see here an historical image from 1966 that depicts Piazza San Marco, so San Marco Square, completely flooded by the water. And as you can see here, the water reached very high level because you have to think that here basically the water can enter even in the buildings in the San Marco Square. And in San Marco Square, there is a UNESCO heritage, this is San Marco Basilica. And in this basilica, there are mosaics, there are treasures in the crypt, there are many things that are very valuable. And of course, the other things that you can see is that basically when you have this kind of events in Venice, you cannot walk there, you cannot visit the city. So Venice is one of the first city in the world, as for flux of tourists. And to give you an idea, Venice Airport, despite the city being like the 10th or the 12th city in Italy, is the third international airport for number of flights. So basically, the city is a touristic site, and of course, as Italians, we are also attached to the city landmarks because for us it represents our history. So you see that when we think about the impacts of these events, I put here a list, and in the list there is not really health because normally the water flowing in the lagoon is slow, so it doesn't cause casualties or people were blessed, but it causes important damages to the cultural heritage. So I will show you in this presentation what are the events that trigger this flooding of the city of Venice. So I will go to the meteorology of these events, and then I will show that using the framework of conditional attribution, we can also evaluate the effectiveness of adaptation strategies against the cyclones that affect the city of Venice and cause the flooding. So let's go to describe the barrier system. The MoSE, experimental electromagnetic module, is this mobile barrier that can raise or be lowered depending on the weather forecast. And it was a very costly project because the construction cost is about 6 billion euros. And it is also costly to activate the MoSE because every time we activate it, we have to pay in the control rooms, in the verification that everything is working fine, and the maintenance, 250,000 euros. So it is a very costly adaptation measure for the city. And it starts its service on 2020. And since its inception, it has been already activated between 43 and now 50 times because there has been some recent activation in November. And we will see whether these activations since 2020 have been effective in protecting the city. So just to give you one more detail, in fact, you see that the access here, there is the city of Venice, and the access to the laguna. So it's basically through 3 doors, water doors, that are protected by these barriers, okay? So we have to raise the 3 barriers at the same time to protect the city from the Acqua Alta. So this is the framework. And now we have to understand what are the hazards that cause these Acqua Alta events and try to make a pathway to attribute them to climate change. So as you can see, in fact, the Acqua Alta events here, just put the impacts is socioeconomic. I also want to stress that Venice is still the capital of the Veneto region. So all the political buildings, few hospitals are in the city. And so also these activities stop when there is Acqua Alta event. So the Acqua Alta events are caused by, of course, it can be enhanced by the sea level rise, by the rain that falls in the region and then try to evacuate through the rivers, and by the wind. So the weather phenomenon causing this hazard is a Mediterranean cyclone. So the Mediterranean cyclones, what we want to see is whether it is affected, already affected by the greenhouse gases emissions, whether these cyclones become more intense or less intense due to climate change, or if there is a prominent role of climate variability. And the sea level rise, we can also have this evaluated by the fact that we have measures in the city of Venice and outside the laguna that track the sea level after basically the 50s. So we have a collection of a time series that tell us what is the sea level during the Acqua Alta events. So the way we will proceed is to focus on the weather phenomena causing the climatic hazard. If you know, for example, what is done in the World Weather Attribution framework, the World Weather Attribution uses a statistical framework to evaluate the change in probability of some hazard related to anthropogenic emissions. But in fact, the world weather attribution, the statistical attribution, can focus only on one aspect at a time, the sea level rise, the rain, or the wind. Instead, our idea here, and the idea of the PhD thesis of Mireia, and here you have a reference both at the original methodology that I developed in 2022 and the one that is adapted for extratropical cyclones by Mireia that is published in 2022 in Climate Dynamics. The idea is that we will look at the object causing this hazard, compound hazard, and in fact we see that when we focus on this date, that is the 4th of November 1966, we have the presence of deep Mediterranean cyclones over the city of Venice. So the way we proceed to evaluate the role of the greenhouse gases emission in these cyclones is that we look at analogues of this weather map in the past period, that for us is 1950-1979, and in the present period, that for us is 1992-2022, and then we end up with a set of dates where we have analog cyclone to the one that caused the flooding. And therefore, taking the present minus past, we can evaluate the changes. When we evaluate the changes, of course, we have to do carefully the statistics, because the change can just be due to the to some variability, in fact. So we can the things that we look at is we do a bootstrap test, and we mix the dates from the two periods, and then we see if the changes are statistically significant. So this is an example of what happens at large scale for this 1966 event. When we look at sea level pressure analogues, we see that the change has a slight intensification of the but significant of the cyclone lower pressure near the minimum that is located on the Genoa Gulf. So just going back to what happened in 1966, because maybe not all of you are meteorologists, when we have a low pressure system, what happens is that we have counterclockwise rotation of the winds. So here on the Adriatics, we have the winds that push the water mass from the southeast to the laguna. And once we have also this configuration, it rains a lot in Triveneto and in the Venetian Alps. And this contributes also to increase the sea level in the lagoon. So we have all these things that are caused by this single structure that is low pressure over the Genoa Gulf and that we call Mediterranean cyclone. So I will recap once again the methodology. And in fact, what we use here to perform this conditional attribution or dynamical attribution of the Mediterranean cyclones that affect the city of Venice to climate change is the dataset ERA 5, 1950-2022. Then we will see that we define an area of interest as a long lat box around the city of Venice. And then we split the data into two periods: highly affected by climate change, that is 1993-2022, and barely affected by climate change, that is 1950-1979. So I show you what happened for the sea level pressure, but with Mireia, and thanks to the reviewers of the paper, we realized that if we go back to this picture, in fact, we have that we have to consider also what happens to the precipitation and the wind, the meridional wind on this sector to get good analogs. Why? Because not all the Mediterranean cyclone produce the same effect on the city of Venice. So we wanted to constrain in this paper the analogues to produce a certain sea level pressure, and this count for half of the weight, because the circulation is the most important thing. But then we also consider precipitation and meridional wind. Then we find these analogues that are just the Euclidean distances of all the data, all the 6 hourly data from 1950 to today, respect to this composite that has a sea level pressure, precipitation, and meridional winds for the 1966 event at the time where the cyclone is at its maximum intensity, and then we look at the differences. And we study the significance and the role of the natural variability. So how do we do practically? Here you see that we have the results computed by Mireia. So the left column is the event in terms of the 4 fields that we use to characterize. So you see low pressure system here over central Italy. We zoom in because we want to focus on what happened in Venice. And as you can see, when we zoom in, we have these cyclonic motions that push a lot of precipitation, well, that cause very high temperature in even in autumn. You see here that we are at 24 degrees. So in fact, normally what happens is that the tourists try to go to Venice during this Acqua Alta because they see that the weather is substantially warm. And then it causes a lot of precipitation in the Triveneto, that is this region here with huge millimeters per day of rain, 140 millimeters. So when you think that an average thunderstorm over the region is 30 millimeters, this is like 5 times a strong thunderstorm. So it's quite a lot of precipitation. And then we have up to 80 kilometers per hour of wind during this, or meridional wind during these events. So then what we can look is the analogues in the past and in the present. So here you see the composite over 15 dates in the past and 15 dates in the present. And as you can see, the composite are not as intense as the event that we are targeting. Yet, when we look at the changes, we see that the events in the present are deeper in terms of sea level pressure minima than in the past. They tend to occur with about the same temperature, and they tend to produce more precipitation and stronger wind, especially on the Laguna and on the Adriatic Sea. So we see indeed these changes, and when we evaluate the influence of El Niño, the Atlantic multidecadal oscillation, or the Pacific decadal oscillation in the occurrence of the analogues, that is how we evaluate the natural variability, we don't find significant signal, and so we can attribute this change to anthropogenically driven climate change. The intensification of cyclones with precipitation and intensification on wind, it has been also found by Mireia in her paper about the storm Alex. And now we have a new paper in review where Mireia is also analyzing other storms who affected France, such as Xynthia, Eunice, and we also have another paper where we analyze mid-cyclones that affected the city of Bologna with the floods in last spring. Okay, so then, of course, my background is not statistics, it's physics. So to make this a bit more solid, I have metrics that come from dynamical system that allow me to assess how confident we are in the analysis that we are doing. And what we can do, for example, is to have a measure of the quality of the analogues, which is here simply the black point is the distance of the fields, the composite of 1966 from all the analogues compared to the distance of the analogues in the past, and this is this blue violin plots, compared to their analogues. So somehow is a measure of how well you belong to a group. So if you are very far from the group, you have this black point that is outside the distribution, and this is what happened for the counterfactual, the past and the present period. So here, for example, what we can say using this quality matrix, oops, sorry, I don't know why I zoom in. Let's see if I can, sorry, I have to restart the full screen. This metric of quality tell us basically that the event is not repeat exactly itself, or that still we can expect that the 96 event is the strongest that we have on the record. Then we have other metrics, for example, predictability and persistence. These are not, the changes are not statistically significant, but they allow, for example, if we have changes in predictability, for example, a decrease in this value of this index D, to say that the events become more predictable, but this is not the case. And we also do not have changes in the persistence time of the pressure minima over this area, although we see that there is a tail of events that become more persistent in the recent time. And so for these events, we can expect more impact because they insist on the Veneto region for more time. And we can also look at the occurrence of the analogues in terms of season. So I remember once again that this red is present and blue is past. So we can see that there is a shift, a modest shift from the month of October to the month of November. And in November, of course, we have that Mediterranean cyclones are stronger. And the fact that we observe more Mediterranean cyclone in November, we also see that we don't see the changes in temperature. But in fact, there is. It's just that we are having the same temperature a month later. And so here the signal is erased. But of course, it means that the mid-cyclone produced larger temperature in November than they did before. Okay, so that's for the attribution. So I hope you have an idea now of how we proceed. So we found changes between present and past periods, and then we evaluate these changes in light of some metrics that come from dynamical system. But now we can also play the game of looking at the adaptation strategy, okay? So we can see if the impacts are reduced once we introduce the MoSE system. So the way we proceed is very, very simple. In fact, we have a list of analogues dates for the past and the present periods. And then for each date, we can use two measures. One is the measure in piattaforma, that is outside the laguna, and one is the measure in Punta della Salute. So if the MoSE is up, the value in Punta della Salute will be lower than the value in piattaforma. But we can think at the value of piattaforma as the values that would have happened in Venice without the presence of the MoSE. And then we can estimate with a damage model that is very simple and that Tommaso has devised by using the data provided by the city of Venice, what wouldn't be in the damages in the city using this value of the sea level. So you can see that this model of damages take into account that basically depending on the sea level and depending on the value that we reach, we have some damage in €1 million. So when we are at the level of the Acqua Alta events of 1966, we exceed the €1 million damage. And we also to evaluate the fact that we pay for the MoSE activation, and then we add every time that the MoSE is activated a fixed cost of €0.025 million, €250,000 to the cost. So the results are much easier. So what we can say is that here is a Bayesian plot of the sea level in the past, so using the measure of Punta della Salute inside Venice, and the event of 1966 is this value that is repeated here for convenience. Okay, so as you can see, in the past we had that the average level was this red line, and the median level then was this other red line. We have many outliers, so this Bayesian plot is not very well converged. But then we can look at the present with the MoSE, so we can take the dates of the analogues and look at what is the sea level inside the city of Venice with the MoSE, and then we can take the dates and see what is the sea level outside the city of Venice. So as you can see, having the MoSE create this lower tail where basically we have lower value that do not affect the city, because you see that when we are below 100 centimeter, we are not having the flooding in the city, but still we see that the distribution is higher than the one we had in the past because of the sea level rise. And we can see also that when we consider the measures outside Venice, we have that the distribution is higher because basically we have this tail that extend to higher values that we see also here when we don't have the MoSE. So from this we can deduce already that we should have some activation at the MoSE in analogues of the event. And in fact, we can make a summary that is this one. We can see the number of times that the MoSE has been activated in the present period with 20 analogues, and we have that we have activated the MoSE the 40% of time in analogues of the 1966 event. So it looks like it works to protect the city against the extratropical cyclone, the Mediterranean cyclones that affect the city. And then we can look at the statistics of the event that is remain, as we have said, a peak of 194 centimeter. And we can look what happens in the past. So in the past, we have 122 centimeter as median value with this confidence interval. In the present with MoSE, we reduce a lot the median, because we have that the lower tail that extend to 59. Sorry. And then without the MoSE, we have increased, and so we would have experienced values that are higher. Well, only 1 centimeter in the median, but as we said, we didn't repeat the event of the past yet. Then we can evaluate also the damages that could have occurred in the city of Venice without the MoSE. So these are the damages that we experienced in the past due to the sea level rise. Even with the MoSE, we have a higher value, but also we have to think that here there is the activation cost every time we use the MoSE. But you can see that it's much higher, the median. So when we have the measure outside the city of Venice. So these differences between no MoSE and MoSE in terms of damages are not statistically significant. Why? Because this value, the value of the distribution, are very similar. So here we did the Kramer-Formiser test, and we see that the values are similar. And there is also this problem that MoSE is a very costly measure. So we have to take into account this. But the reduction is effective in reducing the sea level. Then, is it always good, what we found? No. There is another case that is very interesting. This is, we have analyzed 4 cases. One is 1966, the other one is 2008, and then we have analyzed 2018 and 2019. So for the 2018 cases, we see that there are very little activation of the MoSE against the analogues, and that we don't have a statistically significant reduction of the sea level. But in fact, this storm that occurred in 2018 was the storm Vaya. I don't know if you recall this storm, but basically it's a explosive cyclone. So a cyclone that deepens very fast, more than 24 hectopascal in 24 hours. And you can see that is a monster here in the Genoa Gulf that produce strong precipitation, but also very strong wind. And very strong winds also destroy entire forest in the Dolomites. So here you can see, for example, that there is no changes, that the analogues are not very good, but really not good. There is no change in the cyclone core, although we see a higher pressure over the Adriatic, and then that we have an increase in temperature, increase in precipitation, increase of wind. But basically what happens with these explosive cyclones is that the city is not prepared for them, because the deepening of these cyclones occur very fast, and when it occurs, the weather forecast system of the Protezione Civile, civil protection in Italy, is a bit unprepared sometimes, like it happened in other countries. Not saying that the Italian system is not good, but really these explosive cyclones are difficult to forecast. And therefore, we have problems in activating the MoSE. So to discussion points, our analysis show that we have basically that that the city is protected against the events of 1966, 2008, and 2019 extreme events, but not for the 2018 like events. So the city of Venice was really interested in our results, because of course they could then ask the government, the Italian government, to put more effort in the research and in the forecast of this extratropical explosive cyclone. Okay, and the adaptation assessment, of course, is the very first assessment. The MoSE is in place since very few years. I want to say that the costs are lowering for the activation of the MoSE. So it's going from 250,000 euros to 125,000 euros, and at regime it will be 50,000 euros. And what I want to understand is that so it can appear that the MoSE is not effective from a damage point of view, but remember from the quality analysis of the analogues that we didn't see an occurrence of the 96cc event, yes. And if the MoSE is activated just in one case against this occurrence of the 96cc event, then it can save billions of euro damage, at least according to our model. So, of course, this methodology of conditional attribution can be applied to other events, and I have launched with other colleagues the website, but it is more than a website, it is a platform where we analyze extreme events in a changing climate, that is Climameter, and the colleagues joining are, of course, the one you have seen here in the list of the authors, so Tommaso, Erika, but we have also colleagues, a solid basis at IPSL, colleagues in the US, from Colombia, colleagues in Asia, and so far we have covered over 30 events, and we do this in a very quick time. So if you flash the QR code, you should be able to go to the homepage of Climameter, where we have just covered the San Diego floods that occurred last week, and this allows us to communicate very quickly to the press. And so we realized an interview for NBC explaining why these floods are getting worse with climate change, even in regions such as Southern California. You will find many examples in Europe, just to cite some of them. The storm Ciro, the snowstorm that affected Bavaria in December, or the Scandinavian cold spell, or many Mediterranean cyclones, such as the Medicane Daniel, which affected Libya in autumn. And so I invite you to check out these references and to get back to me if you have any questions. And of course, I'm very happy to answer all the questions that you may have at this point. And I want to acknowledge also the CNRS and the two projects that have basically support a lot this activity, ADP and Exaida, and that are the basis for creating these international collaborations with scientists, and these frameworks of conditional attribution that we use for many events. Thank you very much.
Thanks a lot, Davide. Thanks for this presentation. Is there any question in the attendance? Please don't be shy. Turn on your radio, your camera and mic. And Goneri, maybe? No? You turn on your camera. Is it too?
No, it was just to remind I was live.
Okay, you're live. No question. Is there? So are there some questions?
So I want to stress, perhaps while the questions build up, is that there was, so we had, and this is good when we think at Italy, there is, as you know, there is some political situation where the government is not very focused on the climate change, but still with these studies, there was an attention, at least on the regional and local authorities, and we also did several articles in the press about the findings. And so if this is also a message, like if we cannot find a person to interact with at the national level, perhaps at the regional level, there are people who are interested in this evaluation of adaptation strategy.
Ruth, please.
Yeah, I was really interested in the attribution study you did on the event, the first one you showed. Could you give us some more details about how exactly you did that? We actually did one similarly in Copenhagen a few years ago, looking at a cloud burst, but we used the numerical weather prediction model rather than the climate model to do it. Is that how you've done it here? I would be really interested to hear a bit more about it.
Okay, so I can go back to the methodology. In fact, we don't use climate models. We look at just the analysis data. And of course, when you use climate models, you can take scenarios with CO2 emissions that corresponds to the present and without CO2 emissions, with the pre-industrial CO2 emissions. Here, the way we work is that we look at analogues into two data sets, that is present and past. And then we take difference and we have a statistical model to evaluate the role of the natural variability that is simple. We just have the dates of the analogues in the two periods. And then we see if they correspond to some shift or phase of El Niño, the multi-decadal oscillation, or the Pacific decadal oscillation. Now we are going towards using climate models. So we will have something that looks a bit more like the world weather attribution, but conditional on the circulation.
Thanks.
Ben, please.
Yeah, thanks a lot for the great presentation. I really appreciate it. And I'm also sort of curious about this attribution methodology, because just to see I got it right, it's purely based on changes in atmospheric circulation patterns. So it didn't actually depend on attribution of the sea level change, right?
No, in fact, that's it. The way we work is to condition this object. So we look at the change in this, the Mediterranean cyclones, and then we see what is the sea level changes during the Mediterranean cyclones. So normally what the world weather attribution does is that they focus on this level, the level of the hazards, the statistical attribution, but we focus on the level of the weather phenomena. And this gives us the changes on a spatial level. So this, I think, it's very important. It's a feature of the conditional attribution, because we can really see the difference between the different regions of the domain that we analyzed. I give you an example that is on the website Climameter. We have analyzed the atmospheric river that affect Western Canada and Western USA in December. And in that case, we find that since we have a shift to the equator of the atmospheric river, we see a dipole structure. So the atmospheric river becomes less intense on Canada and more intense over California. So Climameter and this conditional attribution allows to have this kind of geographical details, and therefore are powerful when we want to look at the scale of the cities, for example.
Mm-hmm. So if I may continue, I mean, I don't think we have attribution for sea level at the local level. But if you would have that, in this case, you could actually relatively easily get it into the equation by simply shifting your sea level by however many centimeters are attributed to anthropogenic forcing, then, right?
Yes, in this case, there are the measures, directly the measures that we use at Punta della Salute and Piattaforma. So we use that. But of course, for example, for the damage, we have a model. So even for the sea level, we can have a model that is like statistical or dynamical. We can have data. Just to give you an example, now we're applying these techniques also to fire, using the fire index. Or we want to apply to the level of the, inside the cities when there are heat waves, for the heat waves for which we have mortality data, for example, in Rio de Janeiro or Sao Paulo, and see if using this conditional attribution, we find differences in the two different worlds. The one where, for example, we don't have the favelas, and the one where we have the favelas. So we can think many different ways of applying this methodology, but we need either data or a model to then look at the impacts. So to look at this level here. Hope it's clear.
Yeah, thanks a lot, Davide. I was curious because you were comparing like looking at if the barrier protects from events from the past, but I was curious if you were looking also into the future, and maybe if you could say until when, given sea level rise, the barrier will be effective.
Okay, so this we're looking at this with the city of Venice is the sequel of this paper, and for the moment we are we have another problem, that is the attribution of the floods in Emilia-Romagna in spring last year. And so we are devising the methodology for the spring in Emilia-Romagna, for the spring floods in Emilia-Romagna, and then we will apply this to Venice. So I cannot comment because I don't have the results right now. But there is, of course, a threshold, depending on the scenarios, above which the city is not protected because the sea level is too important. And of course, that's a big fail in the sense that you have to start over with this barrier and make it bigger. And of course, at a certain point, we can also ask what is the effectiveness of this adaptation measure in terms of impacts that they have on the CO2 emissions. So I think it's important also to think that the city of Venice is a city that has put like a limitation on the number of people that can reach the inner part. And I was saying that Venezia Airport is one of the most, the one with the most traffic in Italy. And there is a clear will of continuing these activities of tourism, although we know that then it affects the CO2 emissions, and then this causes a higher sea level rise. So when we think in terms of adaptation, we also think in terms of mitigation, of course. And in Italy, for the moment, this is not really in the agenda. Actually, there is a huge program of the Prime Minister to open new airports to foster the tourism even in periods where there are less tourists. So due to climate change, the argument is simple. Due to climate change, we have higher temperature even in winter. So why don't we have tourists all over the year in Sicily, in Sardinia, in Napoli? And so they are working for that. They're building infrastructure, highways, also railways, but many airports also. So we have to think in all this integrated way. And well, our challenge is to make them understand that there is a point beyond which there is no adaptation possible.
Ruth, yes.
Yeah, sorry, I wanted to ask you a question about this. So you mentioned the 1966 event.
Mm-hmm.
Are these high water events something that go back through the history of Venice, which I know is long and illustrious, or has there been changes? So we have a seaport, Esbjerg, in Denmark, which has had a lot of dredging, and it's really changed the harbor and its vulnerability. Has this been an issue, or?
No, there is an additional issue in Venice that I didn't mention. It's the subsidence of the city. The city is going down and the sea level is going up. So in fact, it's very important to have this barrier because in the future, even 80 centimeters will flood the cities because of the subsidence. So somehow we are trying to save something that we know is going to be at a certain point sinking in the ocean, or perhaps we will find a way to stabilize the subsidence. And I think this we have to think. Well, we have to think. I'm very neutral about this idea. So it's our choice to go to adaptation and mitigation. There is another example in Paris that is the Cathedral Notre Dame de Paris, that we rebuilt exactly as the original, and that gain values after the fire. So it's not related to climate change, but the values that now we attribute to Notre Dame de Paris is even higher than the value it had before the fire. And we have seen that the population is attached to some symbol, such Venice, Rome, Notre Dame de Paris, the cities in Amsterdam, the Denmark. So it's a huge discussion, I think, that we have to have on how adaptation and mitigation can work together to have the less impactful also adaptation strategies in terms of CO2 emissions. But I don't have an answer, of course.
Would that be very nice to hear your answer if you had it? Is there a last question by someone, or shall we close here? So thanks again, Davide. Thanks for this nice discussion.
Thanks, and sorry for not being at the top.
Gunnery, a final question.
Yes, I'm sorry. Is it possible to come back to, maybe it's a follow-up of the question of Ben? When you, in fact, the problem I see is that in the approach to some extent, you separate the thermal effect from the effect of
Yes, I see the expansion, the sea level rise from the dynamical part that is in fact the wind pushing. Yes and no, because in some sense using the analogues date and having the measure of the sea level, the measure of the sea level in the city and outside the city, the sea level measures that we have is the variable that then allow us to attribute to evaluate the adaptation strategy and to attribute the impacts, to do the damage model. Of course, I said this is not a unique way to proceed. If we wouldn't have the data of the sea level, we could have used the model. It's open. So the idea, the very basic idea is that we have dates of analogs in the past and in the present. And then that in the present, we can have different presents. There is not just one present.
Yes.
There is a present where we do adaptation measures, and there is a present where we don't do adaptation measures. And there will be a future where we plan to have adaptation measures or not. So it's this that we can evaluate when we condition to the dates. So
Yes.
not evaluate some mean properties, by evaluating something that happens during the extreme events.
Yes, but you also separate the climate change impact from the impacts of the climate variability.
Mm-hmm.
And here again, I think it's difficult to interpret for me because, for example, in the climate variability, you have the effect of, I don't know, El Niño, which enhances global mean temperature. So
Mm-hmm.
it means that, for example, there is an impact of climate variability on a thermal signal, which is anticipating what we will have in maybe 10 or 20 years. But there is also climate variability related to atmospheric circulations, which is completely different and may not be something that will be enhanced by climate change. And this is where I have difficulties to interpret, in fact, this type of distinction between climate change and climate vulnerability in this attribution approach. Is this something that you have identified and you have a response to this, or?
No, it's really, I mean, it's really an important point to, a limitation, an important point to address when we will go to the future of this study. So for the moment, what we have is that we look at the changes in the phases of El Niño, the AMOC, and the PDO during the different analogues. And if there is no changes, we say that they occur with the same phase. So we exclude this mode of variability to influence at least the circulation part. But that's not perfect because, as you said, there could be delayed effect on the thermal part. There could be delayed effects on the circulation. So the research that we have to do in the next year is to have a model that is more solid on this natural variability. And of course, you are all happy to contribute to this, but is really a limitation of this approach.
Thank you very much.
Thanks a lot.
Thanks for your question. I see that there is. Okay, just thank you.
Yeah, thanks, Davide. Thanks for joining all for your time, and we will maybe invite you for other talks at some point. I know that you will be in our lab at the end of the week, and that would be great to have further occasion to discuss with you. So
I'm looking forward.
And see you all soon. Goodbye. Good afternoon.
Thanks again. Bye.